engineers at EPFL have developed a predictive control model that allows swarms of drones to fly in cluttered environments quickly and safely. It works by enabling individual drones to predict their own behavior and that of their neighbors in the swarm. There is strength in numbers. That is true not only for humans but for drones too. By flying in a swarm, they can cover larger areas and collect a wider range of data, since each drone can be equipped with different sensors. One reason why drone swarms haven't been used more widely is the risk of gridlock within the swarm. Studies on the collective movement of animals show that each agent tends to coordinate its movements with the others, adjusting its trajectory so as to keep a safe inter-agent distance or to travel in alignment. In a drone swarm, when one drone changes its trajectory to avoid an obstacle, its neighbors automatically synchronize their movements accordingly. But that often causes the swarm to slow down, generates gridlock within the swarm, or even leads to collisions. Enrica Soria, a PhD student at EPFL's Laboratory of Intelligent Systems (LIS), has come up with a new method for getting around that problem. She has developed a predictive control model that allows drones to not just react to others in a swarm, but also to anticipate their own movements and predict those of their neighbors. She says that their model gives drones the ability to determine when a neighbor is about to slow down, meaning the slowdown has less of an effect on their own flight. The model works by programming in locally controlled simple rules, such as a minimum inter-agent distance to maintain, a set velocity to keep, or a specific direction to follow. Surya's work has just been published in the journal Nature Machine Intelligence. With Surya's model, drones are much less dependent on commands issued by a central computer. Drones in aerial light shows get their instructions from a computer that calculates each one's trajectory to avoid a collision. But with this model, drones are commanded using local information and can modify their trajectories autonomously. Tests show that Surya's system improves the speed, order, and safety of drone swarms in areas with a lot of obstacles.